All right, we'll pick up where we left off then. On the interval from 1 to 2, the function is negative. The first derivative is negative, which tells me that I'm decreasing again, and the second derivative is negative, which tells me that I'm concave down. So I'm going to use a little notation here. The function is decreasing and concave down, and it's negative. So you can kind of see how from 0 to 1 is going to hook up with from 1 to 2 at the point x equals 1, y equals 0, and we're going to have a horizontal tangent line there. We're going to have this stationary point, and it's going to make that little dip, kind of like a sidewards S almost. All right, let's go on to the point x equals 2. At x equals 2, the y value is negative 1. The first derivative is undefined. The second derivative is undefined. So I record the information that at x equals 2, y equals negative 1, we have a critical value because the function is defined, but the first derivative is not defined, and the second derivative is not defined. So we have a critical value, and that has to be either a sharp turn or a vertical tangent. It could be either of those at that point. And let's look at what happens from x equals 2 to x equals 3. The function is negative. The first derivative is positive, which means we're increasing, and the second derivative is negative, which means we're concave down and increasing. So I make a note that we are concave down, increasing, and we are in negative territory at that point. Alright, so I think we've looked at everything. Now we've only looked at the values between 0 and positive 3, and this is where the even function, the evenness of this function is going to come in, even though we've only looked at from 0 to 3. Because it is an even function, we're going to be able to reflect whatever we find over the y-axis and replicate it from x equals 0 to x equals negative 3. So let's start to look at some of the questions that we have here. And A asks us to find the x-coordinate of each point at which f attains an absolute maximum value. Alright, so where do absolute maximum values occur? The absolute maximum values occur at critical values or endpoints. So the endpoints are going to be negative 3 and 3. And then we had critical values also at x equals 0, x equals 1, and x equals 0, 1, and 2. So that gives us a total of 5 candidates for the absolute maximum and absolute minimum. The largest of these will be the absolute min, the smallest will be the absolute max. So we're actually given the y value for 3 of those points. At x equals 0, y value is 1. At x equals 1, the y value is 0. And at x equals 2, the y value is negative 1. Now, I have to remember here that if we have critical values to the right of the y-axis, we will have mirror images of those critical values to the left of the y-axis. And so at x equals 0, x equals 1, and x equals 2, we also have critical numbers, and whatever we find for those points, the findings will hold also on the left side of the y-axis. So far we can see that at f of 2 and negative 2 we have what appears to be a minimum. We need to see whether the function after it leaves 2, sorry, that's 2 and negative 1. So we need to see after it leaves x equals 2, y equals negative 1, does it go up or down from that point? And the answer can be found in the derivative of f from 2 to 3. It's positive, so it increases after that point, and therefore f of 2 is an absolute minimum. And so reflected to the left of the y-axis, f of negative 2 would also be an absolute minimum. Now it appears that f of 0 equals 1 is the maximum, and from 0 to 1 that function is decreasing. So f of 0 equals 1 has to be a maximum, and there's no reflected value for that. We'll carry in the next video.